Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes.
Well, welcome to this Advanced Tips and Techniques video series. This is episode 19. And this is about using delete, replace, move, and heal face. So in this episode, we're going to talk about one of my favorite sets of features, which are the delete, replace, move, and heal face tools. If there ever was, I almost was tempted to call this episode the tricky tricks of SolidWorks tools, because it seems like these tools, more than any other in SolidWorks, are just magical and can get you through some difficult modeling to be able to accomplish things that otherwise would not be possible. So they're almost like magic, and they're almost like tricks. So anyway, I think we're gonna have a fun one with this one, and I look forward to going through it with you. Hope you can learn something new about these tools and take advantage of them. I use them quite frequently. They're on my S key shortcut, and they are very useful for a number of things, and I'll get to that in a moment in a slide. But what we're going to cover is this set of tools, which can be accessed through the insert face area in your menus. And they're basically four tools I'll talk about today. And that is delete face, which gives you the ability to eliminate geometry from your model. It also allows you the ability to convert your solid model to a surface body by eliminating one or more faces. And it also has an additional option to where you can patch one or more faces, and this is good for a number of things, including import models. The second area we'll talk about in these tools is replace, which gives you the ability to replace one face of the model with another surface body or surface face. And it is also a tool I use quite frequently, especially in part modeling, actually, because it's very robust, and I'll explain why as we get into our examples. The third area would be the move face. Now this is different, and it differentiates itself from surface copy or surface offset, in that it's not creating a surface, but it's actually moving a face on your surface or solid body. So it's either moving it, translating it, or rotating it. And also very useful as a modeling tool, and also very useful for cleaning up your model. And we'll get more into that. And then the fourth area in these tools is called heal edges. Not used that frequently, but I do use it occasionally, and it's very useful for simplifying and cleaning up your model. especially when you have features that are producing some not so expected results in your model. We'll talk more about that when we get into the example models. Some of the typical uses for these tools that we'll talk about today are, first and foremost, they're used to simplify and clean up your model by removing unnecessary faces. And this is important because you may have experienced that sometimes you can't shell or radius an edge or do further features until you get to the point where your model is cleaned up and able to do that on these parts of your model. It's obviously very useful for when you get imported models that come in and they don't come in quite right, even when you use import diagnostics and repair it. There are some areas where maybe you have to delete faces and rebuild them, or do a replace face to make the model correct. These tools are also important and useful when trying to overcome problems with various features like the combine feature. When you're combining two solid bodies, they may have two faces that seemingly meet, but it produces a zero thickness error between them, and I'll talk more about that in an example. Well, you can use a replace face to overcome that, and I'll show you how. And I've shown this in previous episodes where the delete face with patch is very useful for cleaning up setback points in fillets, and basically the blending between fillet edges coming together. And by being able to use the delete face option with the delete option where you're actually removing a face of the solid, you're able to convert your solid to surface body. And that's useful for what I call circumventing the feature tree and getting around it by going from solid to surface and back to solid. Basically think of it as a technique for modeling. But we'll talk more about all of those in example models where you'll see them more clearly, I hope. So with that, we can move on here. But I think what's key in really understanding these features, and what I want you to understand, is the difference between topology and geometry. And I think if you can grasp the concept here, you'll really understand how to better use these tools, because these tools are all about this subject. It's a basic concept, and basically in CAD, that if you take, for instance, a box or this rectilinear box, it has 6 faces, obviously, right? 4 sides, the top and bottom. Now, if you change the dimensions of that box, its topology is identical, but its geometry is different, okay? If you add another face to that box, then its topology changes. So when I refer to these terms, topology and geometry, this is what I mean. So by adding a face, you're changing the topology. By changing the dimensions, you're changing the geometry. And you can do both, obviously, in this third example. So that's the basic concept. And the reason I mention this is that these tools, move, replace, and delete, are all about this. They will either work or not work depending on the topology or geometry of the part. And I'll explain that a little bit further in these next few slides. So replace face generally is used when you want to change the geometry apart, but without changing the topology. So for instance, in this upper example, you have a surface body that you created, and you want to replace a face of the model, that is the top face of this box, with that surface body. When you do that, you're not changing the topology because you're just substituting one face for another. Now, the caveat in that's quite interesting and actually an advantage is that that surface body could be made up of more than one face. It could have multiple geometry in it and still replace the one face of the model. Now, unfortunately, the opposite is not true. You generally cannot replace multiple faces of the model with even a single surface body. And the workaround there basically is that you have to do it successively. That is, you have to replace one face of the model, then create another replace face feature and replace the other face with the exact same surface body. Just a limitation. I'm not sure why it exists. Sometimes it does work, many times it doesn't. So just be aware of that. It's not you. It's just the limitation of the tool. So the move face feature is a very valuable tool for many things, and we'll talk more about why it's useful. But basically what it does is it takes a face or faces of your surface or solid body and it translates them. It either offsets them or translates it along a vector, or it can even rotate along an axis. It has limitations too. It generally cannot change topology, but there are exceptions. I'll talk about that in a second. In the example here where you have this box with a variable radius on it, you really cannot, if you want to take all the tangent faces of that model and offset them, you can do it, but you can only do it up to 1.5 millimeters. And the reason being, if you see there, the minimum radius of that variable radius is 1.5. So if you went beyond that, you would be changing the topology in a way that the model can't understand how to heal, because it can't understand how to do a variable radius on part of the model. So just an example of where you might not be able to do move face. There are some exceptions to that, and actually there's more exceptions than I realized as I started to research this a little bit more. You can move faces and change topology. For instance, if you have this pocket here and you move it up and move it in a dimension beyond that top face, it actually will eliminate the pocket. So it's powerful in that way, but I'm just saying that in some cases it'll work, in some cases it won't. It generally has to do with whether the modeler can understand how to heal the model after you've moved the face a certain direction or rotated it a certain direction. It'll either decide that it can resolve and heal the model into a new topology or not. So just be aware of that. I'm amazed at how many times it does do this and change the topology. So just with that, just be aware of why that is. So the third tool, Heal Edges, is a useful tool. In the example here, there's a cut on this algorithmic face that results in what I call a dirty edge. And that you've maybe seen this in some of your models where you have unexpected vertices along an edge and you're not sure why. Well, I can show you why when we get to the model that occurs. But in any case, the Heal Edges, excuse me, the Heal Edges command is about simplifying your model and cleaning it up basically, and can be very useful when you get to a certain point where you're shelling or doing a radius and you can't get past it. It could be because of this condition where you have laminar edges, that is connected edges that of the model that are exhibiting multiple edges. So this works on both faces of your model that exhibit a condition where they need to be healed. You can also work on a single face and just work on the edges of a quote floating face, which is valuable too, and I'll try to show that in some models. So the fourth face tool, Delete Face, is useful for when you want to eliminate topology from your model. So it has three options, and the first option where you're trying to do this, that is simplify or remove faces from your model, the delete and patch default option, you pick a face or faces, and depending on whether it can satisfy the topology geometry of the model, it will remove those faces from the model, as an example here where this rib is removed from this bracket. The second option is delete, and this is without patching. So by definition, when you remove a face or faces with this option, you're actually eliminating the face from the model. And on a solid body, when you do this, it removes the face and converts it into a surface body, as you can see here where this face is removed, and now you have a non-manifold surface body. The third option is delete and fill, and this is similar to the first except for extending and healing the model with the surrounding faces, depending on the topology and geometry. It instead creates a new face over the face or faces that you've selected. And you can see here where there was a number of faces that then were delete and filled tangent to create a new face solution. Why don't we do this? Let's get into example models, because I think showing these features is probably more valuable than me continuing to talk about them. And I know that's what you'd like to see, is them in practice. So I think the best way of illustrating these tools is just let's get into some sample models. Starting with our first example, I think I'll move through these example models pretty quickly, but we'll do them in the order that I presented them. So it would be, what was it? Delete, replace, move, and heal. So we'll go through the solutions that way. So starting with delete face, its default mode, which is delete and patch. I want to remove all these features from this model and then move on with further modeling. But I want to do it in a rather quick way. And if you saw one of my earlier videos, I showed how to do this very quickly. One of the things I like to do is to go with wireframe and then make my selection lasso. And then with that, you can also, you can also put it on face. You don't need to, but if you want to, you can filter it to faces and then just simply lasso those areas so you have them quickly selected, and you've used delete face with the default mode, delete and patch. So it's that simple. Now, one of the other popular uses for delete face is to repair imports. And that's the case with this carburetor design that came in and threw me a bad face that you can see here in this folder. So we need to do something about that. And so delete face is a good way to do that, I think. So we can go ahead and invoke delete face, but this time instead of delete and patch, we're going to delete this face from the model. And with that, what we've done is we've turned the rest of it into a surface body with the intent of rebuilding this face. And so I think quickly we can just go to our fill surface, grab one of these edges, say open loop, and then grab the inner loop and leave it all on contact, merge, and solid. And now we've repaired our model. And I always want to check, though, to not assume that. So let's go to evaluate and let's check our model to make sure that we're good. And yeah, we're good. So we've repaired that problem. We're using delete face and then a fill. So it's really amazing what you can do and what you can affect with these tools. let me just show you. So here we have an import model that is kind of whacked out in these areas as well as this area, just kind of a mess. And I need to clean it up to the point where I get back to the basic angle bracket geometry and then rebuild on top of that. So if we take a look at the solution folder, we unsuppress it, we get to this. And this is all using basically the delete and replace tools. So just stepping through this, we first are going to delete this face back here. And I think, this second, sometimes it's hard to figure out what I'm actually doing. Yeah, I'm deleting this face up here. And sometimes you have to do it this way where you successively delete faces and not try to do them all at once, because the model, by deleting one face, extends and simplifies the model to be able to go further in deleting faces. So again, I just taken all of these faces for that bracket, or I'm sorry, that flange, remove that. And then I'm doing something kind of sneaky here. I'm taking this face right here, and I have to do this in successive order to maintain the model. I'm deleting those faces to extend them, and then I'm removing those faces, and then bringing it back to a full round condition, which is the way it was originally modeled. And then to get this back, I'm going to use replace. But before I do that, I need to build some surface geometry that mimics this profile. And then I'm using replace to replace this face, and this face. Remember what I said about replace face? It doesn't usually work when trying to replace multiple faces at a time, but doing them successively, you can do that. So I finish up the model, and I've got it to a point where I can basically start what I call remodeling, and we won't really get into that, but basically I'm just modeling back the features from before. What's key on that is that I did an offset surface right here to kind of copy those as a reference. So when I did clean the model up, I was able to go back, and show that as I modeled these features in. So that's the power of delete face and what it can do. So now we're going to move on to replace face and show you a few examples in the way that I use it, both as a modeling tool and as a cleanup tool. Let's start with a modeling tool, and here's a button that I can't revolve this face to complete the dome because this is elliptical shape. So a method I use often is to instead build some surface and then replace this face. So that's what I've done here, is that I've built a boundary surface, and that boundary surface is very simple. It's basically my curve here, a sketch curve, and then this edge. And as you know, with boundary, you can build a boundary with a 1 first and 1 second direction sketch. And that's what I've done here. So I've just built a general surface here, and then I take that and I replace it with this surface. So if we just unsuppress this, you'll see I take that surface and I replace it with that. So if we roll into that, edit that feature, you can see I have my boundary surface, replace it with this face, it moves it up, it eliminates this face, and that's my solution for getting that cap there. So a few other ways to use it in modeling. So actually to use it to clean up in modeling. So this is a swept here to give this appearance gap, but the sweep isn't extended or completed past this point. So I really need to eliminate this face. So I first would try delete face, to do that and see if I can get rid of it that way, and I can. But sometimes you can't do that, so you have to use replace face. I'll show that. Let's use delete face to clean up these surfaces here. I'm just going to pre-select them and then go to my delete with patch and clean those up. Okay, and then we'll go ahead and we'll try a delete face here again to remove this face. But an alternate method to do that would be, if that doesn't work, is to first copy this face by making a 0 offset surface. And then with that selected, go immediately to replace face. You can see it populated your surface, and then pick the back face. And what it's going to do is it's going to trick it into thinking that that needs to be the face. And so that's another way to eliminate that geometry. And then of course here in this corner, I believe we can use a delete face on this area to just basically extend this face. And that's pretty much it for cleaning that up. And so that's how you would use delete and replace. One of the most basic ways to use replace face is to use it as a modeling tool. And so here we have a base feature, and we want this face actually to become this face. So what's really nice about this is that if I were just to model this by building a sketch here and then extending it up to this face, it probably wouldn't work because the face is not in the entire bounds of the profile sketch. The nice thing about replace face is that it doesn't matter that this doesn't completely bound the sketch. It will just substitute it for this face. So if we use replace face and we use this as our surface and we want to replace this face, then it will work no matter the size or extent of the surface. The target will extend up to it. And that's why I believe it is a very robust feature in that way for modeling. So really quickly, I need to show this example, which is actually from years ago, an actual use of replace face that proved to be very valuable, and it worked out well for this model. So the client decided that instead of a turn valve, this needed to be a ball valve. That is, you've seen these on faucets where instead of this turning, you move it up or down or left or right. So this mechanism here needed to change very quickly for the rendering and then subsequently the mechanical design. So the solution here would be basically to build your ball valve, or your revolve surface, which I've done right here. And I've just built like 180 degrees of it actually. Actually, when I tried 360, it didn't work. So I tried 180 and it does work. So with that, you can take and build your replace face by picking that underlying surface body that you revolved and then replacing it with the existing face. And so now you get your ball valve very quickly and easily using the replace face tool. Just to further build on the subject of using replace face as a modeling tool, again, here's a base feature, very simple, and with replace face I was able to turn it into this. And that is without using cuts or revolves or anything. Basically, it's a number of surface bodies that then are used to replace various parts of the model. And there's a little sneakiness in here too, where you can create additional topology, like I've done this before often in my models where I want to replace this edge with this face. So first, if you just create a simple chamfer, then you can use that face of the chamfer to replace it with this surface. So another way to use replace face for modeling. Now, perhaps the most valuable get me out of trouble use of replace face is when I have bodies in my SolidWorks part that don't Boolean. That is, using the combine command. If we go to our combine and we want to combine these two bodies, they don't combine for some reason. And it's usually due to modeling error or tolerance error if you look closely at it. But in this case, I don't want to really go back and change anything. So I know that these were built on the same face. It's just that they're not meeting each other, and there's probably a zero thickness error here. So here's my method for resolving this issue. If we isolate this model and basically just go here and create a copy surface. So offset with 0. And then go ahead and hide this body. So now what we have is this lower body with a surface copy of the upper body. And using those, we can take that surface offset from the upper body and replace the face of the lower body. And I did a double selection there. So I've taken the lower face, replaced it with the upper surface face. And now I believe if we go ahead and try our combine again, it'll probably work. So we're going to combine this and this. And yes, they combine. So that's a way of fixing up zero thickness errors to get them to combine. So have you ever had this happen where you built your model and you built half of it, and that's a good thing because then what half mirrored is robust to the whole model. You go and then you're ready to mirror it over the part line. So I'm going to take this body and mirror it across the mid plane or the right plane, and I want to merge it together. And you do that and it fails. And you're not sure why, because it looks like everything is modeled correctly, but maybe it's something with a tolerance error, and that's usually what it is. Maybe it's the way that when I modeled these surfaces and trimmed them back, something happened, or the knit feature actually moved the surface enough to make it this surface not lie on the right plane. So if you look really closely, yeah, that's the case here. Something happened with the knit to actually move that off my midplane. And this is the actual problem that's happening. It's resulting in a zero thickness error. And with that, if it's trying to solve, it can't solve it, because if it wants to combine those two bodies into one, it results in a zero thickness error. Up at the top there, what results is a non-manifold solid. There's no way that it can make the two bodies one body because of this gap. So we need to resolve that. And so this happens, rather infrequently, but it does happen to me. And so what I'll do, usually in this case, if I can't get bodies to mirror across the midplane, I immediately go and we're going to create a copy of this surface, but actually what we're going to do is we're going to go into the right plane and just create a simple dummy copy of a planar surface. Okay, like this. And then with that, I can take that surface face and replace it for this face. And now when we go to do the mirror, it'll probably work. So we're going to pick the right plane, which is our mirror plane. We'll pick this body, we'll merge it, and it works. So that's usually the problem when you run into that, and that's usually the first thing I try. So that's my encouragement to you. So moving to Move Face as our next tool. Move Face can be used for many things. It can be used for extending faces, repairing and closing gaps. But did you know it also can be used as a patterning tool in a way? Not that you couldn't pattern this around this dish, but you can actually take surface or solid bodies and you can move them, but you can also rotate them, and you can also copy them, and you can copy them by multiple. So that's what I'm doing here, is that I'm just making copies of that. So now I have a bunch of surface bodies sitting in a solid face, and then I can use the intersect tool. If you haven't used it, very valuable tool. And even though those are open surfaces, that they're not closed up, intersect can understand how to take those surfaces, combine them with the solid, and then make one uniformed solid body. But probably more important use for Move Face is just to modify your existing geometry. And so in this case here, we've created a rib, and the rib is built from these internal edges, but this external edge, but when we extend it down to the floor, we get a gap here. And the first thing I would always try to do is to use delete face, but I think in this case it's not going to work. And that's because, remember we talked about topology? By using delete face, it has to also remove this inner edge that sits in between that delete face, and it's just too much for it to try to do. So what we're going to do is we could probably use replace face also, but maybe a quicker way is to take that face and let me first get into my Move Face tool. We'll take that face and we're going to then extend it by a certain number past the kind of target wall, and that would be 10 millimeters. That's true on both sides here. So if we go in and do a select other and pick those faces, you can see the preview is now extending it and actually removing it, so it's changing the topology and the geometry at the same time. Now the only danger about this tool, parametrically speaking, is what this number is right here. And so if this were to, the geometry, the features, the parent feature of this were able to change quite dramatically, this could fail depending on what number you put in here. So like if I put in 1, you can see it's not extending all the way. If I put in 10, it's extending all the way. And that's probably pretty safe given that this isn't going to change that much. So with that, now I've used the Move Face to repair or modify my model and used it as a modeling tool. So the last of the tools that we'll cover in today's episode is heal edges. So with this assembly model, we can see that we have some broken, or what I call dirty edges in here. We have 3 of them here. And so I'll go to my Heal Edge tool, and I'll pick the 2 adjacent faces. And with that, I leave my angular tolerance and edge tolerance is actually quite high here, but the higher the better. And go back into the feature here. You can see if we heal edges that we've reduced it from 23 to 21. And so with that now, we have a single edge going from 23 to 21. It was reducing it 2 edges. So now we have a single edge, and that's what I want. And that's a better cleanup for the model. So that is a very simple example of how to use Heal Edge. So there's a little more complex example of using heel edge. And I'll just walk you through what happens here. So you can see we have some internal vertices here on this edge that we want to get rid of. We have a couple of them here. So again, I'll go to my heel edges. I'll pick these two faces and try to bring my tolerance really high. And you can see that with this, no matter what the tolerance is, I really am not able to repair this for whatever reason. I did a heel edge on it. It still has 3 edges there. So we got to get a little more creative. And so that's what I've done in this model. And if we show the solution here, I'll just kind of walk you through it. So what I did first was I need to repair this edge by other means than heel edge, or maybe isolate it and then repair it. So I've created a copy of this surface that is surface offset by 0. And then I go ahead and I delete the underlying face. So let's just delete that so you can see what I've done there. So made a copy, deleted the underlying face, and then what I do is I do a heel edge on that copy. So if I were to show that again, well, no, I guess what I'm doing here is I'm doing a heel edge on this open edge. Now remember I said that heel edge will work on open edges as well as laminar edges. So when I do this, you can see that I've reduced the count from 29 to 27, and I have a single edge. Okay. Now I'm going to do that also with the opposite edge, that is the surface copy. So I'm going to pick that surface copy and I'm going to do a heel edge on it from 8 to 2. Okay. And then I'm going to extend the edge of that surface copy so it extends past the other one, and then do a surface trim. And now I have a manifold surface body that I can make a solid also. At least let me prove that out to you by going to thicken here and pick that. And no, it doesn't work. Okay, so what's going on there? So I think we need to, oh, I know what it is. I need to knit this with this. So let's go ahead and do that. And now we can probably take that and thicken. Yeah. So there we go. So that's how I got through that. It's a little complex, but sometimes it happens where you have to get a little creative on how to repair these models and go forward. So to show once more how you can use heel edge on open faces, the objective here is to replace all 4 of these with a single face. But if I try to do that just with this, you can see if I build a fill here, it's going to leave those edges because I have a number of broken edges here that the new surface fill that I repair this with will pick up on those. So instead what I'll do is delete these 4 faces from the model, make it a surface body, and then I'll use my heel edges tool on this face and this face, which have these broken dirty edges, heal those. And so now I have a single edge that I can then build a more clean surface on, and maybe that's a boundary surface, for instance. So let's just go ahead and pick these 2 edges, make them tangent, of course, and then in our second direction we'll pick this edge, and then we'll use our selection manager to pick these 2 edges. And now we've got something we can knit in and make it solid, and that's our solution. So I just wanted to end with showing why these broken or dirty edges exist. And one reason is modeling, and it's kind of human error. But one way that this can happen, and I've used this example to show that. So what I'm doing here is I'm creating a split line on this surface here. And so if we just look at the split line feature, I have a curve down here. I'm splitting this face. The result is an edge on this existing face. And then here what I've done is I've actually created a swept surface, and it's one of the path of the guide. I'm not sure which one it is here. Is that split edge. And so when I do that, and let's go ahead and show that surface, you can see that, well, I talked about this in an earlier episode on sweep. You have to understand that sweep is basically taking a profile and sweeping it along a path and guide curve. But the guide curve or path, or let's just say the guide curve, is an approximation. So it's building loft sections from the beginning to the end of the path, but the guide curve is just an approximation of where that is. So what results is kind of, if I can say this correctly, the surface is going over and under this existing model face and trying to approximate what material will be taken away or what material will be kept. And that's true even if I extend this. So this makes it even worse. So I've extended the face, and now what I have is, you can actually see in the graphics the overlap. So you see where it's actually overlapping part of the solid face here, and then it's underlapping the solid face. Well, when I do that, when I extend that, and then I use it as a cut, what will result is you'll see the result as this broken edge. And that's why you do not want to model this way. So how would you do this? Well, I would say, instead of using a split line, use a curve. So project the curve. So instead of splitting the face, use a curve by projection and project it onto this face. And then use this as the path or the sweep, because remember, this is just a curve. It's not actually creating any new topology on the model. It's just a curve sitting on the model. So if we go ahead and just delete this split line and then go into our sweep, and first we have to make sure that our sketch is not dangling anymore, that actually, and this is probably a better condition, is just to say we're going to pierce this with the curve. And then when we go and repair our sweep, we're going to use not the split line, we're going to use the curve as our path. And then when we do a cut, we see we get a clean edge, because there wasn't any pre-existing split edge there for it to try to figure out what material to take away and which to keep. So I just wanted to explain that you don't have to use the heel edge tool if you're cognizant of how you're modeling, because sometimes it's your features that you model that result in having to use the heel edge. So I think that's all we have time for in this episode. I have many more examples of this, but we're running out of time, or we're probably over time by now. So we'll just leave it at that. And if you have any questions, just email me.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.